Well, hi everybody. Thanks for coming back. Appreciate it. This is just a little bit more information about what you should know when you're starting to build a performance engine, or your engine in particular. Some of the things that I don't know are being talked about enough, and I think maybe should be talked about more. Last time we talked about cam bearings and how to feel, how to clean up, how to prepare them for install. I'm sorry I installed them in the block without you here, and I wanted to talk a little bit about it so you understand a few things. Cam bearings are installed in the engine block with what's called crush. What that means is the hole in the engine block is smaller than the outside diameter of the bearing. So the bearing has to be driven in with a special tool, a cam bearing installation tool, and it's done, under duress with a hammer. You basically pound them into place. But even though you're using a precision tool like a hammer, you still need to measure and understand and know and set what your crush is. In that case, I used my fixture gauge, my dial bore gauge, and my outside micrometer. I measured the outer diameter of the bearing. I measured the inner bore of the block where that bearing is going to go. And the difference between the two is crush. That is tunable. What I like is about 8 10,000ths of an inch to 12 10,000ths of an inch crush in this application. If it was too tight, if I was seeing, 18 10,000ths, 20 10,000ths, that's too tight and I'm going to hurt the cam bearing, I would actually hone the bore that the camshaft bearings go into in the block. I already had my machine shop Bell engines check the bore, because they did an align hone on the block anyway, because we converted it to an ARP main stud kit. We'll get into discussing that in a later video. So while they had it fixtured in the machine and we're doing the align hone, I had them touch the cam tunnel to polish just a little so that I could get my 8 10,000ths to 12 10,000ths crush on my cam bearings. So I've already installed them in the block. I'll take you over and we'll show you that in a moment. But next I wanted to demonstrate a little bit of what you need to be thinking about when you're working on these. Because my next step now is to consider my cam bearing oil clearance. In this particular application, this race engine that I'm building, I would really like to see 29 10,000ths to 31 32 10,000ths of an inch. So right around 3 thou is what I'm trying for. So what I've got fixtured up here, I've got my V blocks, I've got my camshaft. I've washed the camshaft because it was coated in an anti-rust coating from my machine shop. So I've cleaned it in solvent, then I've wiped it down in denatured alcohol, again, to try to make sure that everything is just as clean as I can possibly get it. And this is going to get washed again before final assembly because I'm touching it. Nothing in my engines touch flesh. Everything gets cleaned, everything gets wiped down with denatured alcohol. Then I glove up with neoprene and my assembly goes together with no fingerprints in the engines. The contaminants in our fingertips, we can't see it, we don't know it, but it's real. So anyway, what I've done on this camshaft is I've taken my outside mic and I've gone in and I've measured all of these bearings. This is where the bearing in the block will ride on this camshaft and support this camshaft in the bore. So it's been measured. I read my micrometer. It's a 1 to 2 mic, so the measurement starts with 1 inch. 9 showing, 9. 2 small dashes just about perfect. So each small dash is 25, so that means I'm almost at 50. but I'm actually showing 48. Look for the lineup, 48.9. So that is a very accurate measurement done by feel. You want to be very gentle with everything you do, and it should you should feel that little bit of resistance to tell you that you're in contact, but not enough that is binding. And that's how I've gotten all of these measurements. Now this tool is a dial bore gauge. Incredibly accurate tool. For doing inside bores, you could use what we call a transfer gauge or a snap gauge. These work, but they have a tendency to not be as accurate. I'll show you one of them real quick so that you can see how they work. It's a little T, and when I open the thread at the bottom, they snap out. And then when I go in a bore, they're spring-loaded. So they'll center in a bore and pick up that dimension. And when they do that, I snug this, take it out of the bore, and then measure it with my outside micrometer to compare the measurement. The only problem with that is anytime you're comparing a measurement, there's room for error. This particular tool, if not used properly and with a lot of experience, can generate errors. It's not the most reliable tool. I do use them if I have to. In all honesty, I had to use them in the block here because my dial bore gauge only goes down to 2-inch, and I need 1-inch 950 set up on the dial bore gauge. So what I did is I've got the bearings in the block. I went in with my 1 1/4 to 2 1/8 inch transfer gauge, measured the bores of the bearings installed in the block, documented that information, then did the math. I now know for a fact that I have 28 10,000ths to 32 10,000ths oil clearance on every single one of these. And I'm happy with that. I'd love, in a perfect world, I would love 3 thou perfect. But unfortunately, we're dealing with tolerances that have plus or minus 2 10,000ths, 3 10,000ths on the grinds of these and on the polish of them. Now, in this case, we did have to polish this camshaft just a little, and it was done with a cork belt, a cork polishing belt, like we would use for polishing crankshafts, or in this case, polishing a camshaft. We did have to touch these ever so slightly. That's why we see a little bit of deviation in our numbers. That's not going to hurt me. It's got me where I need to be for correct oil clearance on these bearings. So in my last video, we talked about you should have the ability to ask your machine shop, show me. Well, now you've seen it. These are the tools: dial bore gauge, outside micrometer, dial bore gauge setting fixture, V-blocks, accurate measurements. Now you know what to look for when you go to your machine shop and you ask them, show me how you set up my oil clearances. It's your money, it's your right. I think that's going to be it for this. Actually, I'll take you over and I'll show you the block, because I wanted to show you those cam bearings installed in the block. So that'll be my next video, video number 3 in this session. I'm going to be documenting as much of this engine build as I possibly can. I think it's important that we, the consumer, we the end user, for the money that we pay for parts and the money that we pay for shop labor, we need to know more. We need to do our part and know more. So if you have any questions, if I've explained something that isn't crystal clear and you need more, ask me. I'll update. Let's get knowledgeable. Let's know what we're talking about when we build engines. I've seen a lot of people online that say, oh, I build my own engines. The only tool they own is a hammer. How do you build an engine? Let's work together and learn. Thanks, guys. Appreciate it. Have fun.